Hello, class. Once again, it's Mr. Kablan, and I'm here with the third lesson for Chapter 7, dealing with the second type of factoring that we're going to see in this chapter. And in this type of factoring is what's called a difference of squares. So let's get right to it over here. So in the previous lesson, I introduced you to a type of factoring called common factoring, which was basically the opposite of the distributive property, where you had to find what was called the greatest common factor, which was a number, a letter, or a combination of the two that went to every single term in an expression. Okay, this one here is way different. However, believe it or not, even though this is way different from what we did in the last lesson, okay, the actual technique behind it is actually relatively simple. So let's get right to it. So when we're dealing with the difference of squares, every question we're going to look at in today's lesson will look exactly the same. And you're probably wondering, what do I mean by that? Well, in a difference of squares, when you have an expression, they will always have these properties here. They will always have only two terms. I repeat, two terms, and both terms are going to be separated by a minus sign. So a good example of this will be x squared minus 25. All right, so notice it's two terms, okay, where both of them happen to be separated by minus sign. Now you notice that the term that's missing, and you're going to see this from all the questions, is that you notice there's no x term on its own. The last two lessons, or for the most part, especially the first lesson dealing with the distributive property, okay, or the multiplying two binomials, remember that all our answers always wound up with three different terms: an x squared term, an x term, and a number. In this case here, we only have two terms, an x squared term and a number. Now, anytime you see an expression where you have two terms separated by a minus sign, specifically a term that is squared and a number, we have to perform what's called the factoring of a difference of squares here. Now, the keyword I want you to see here is the word binomial, because as I said several times already, every question we're going to look at in today's lesson will only have two different terms here. All right, so just to break that down there, we have a subtraction sign that separates them, and you're going to see that in all the examples for today. And basically what we're going to look at here is how we can get to this, okay, and then come up with a factored expression which consists of two brackets, sort of like what we did in with multiplying two binomials, obviously just the opposite of that. Okay, and basically what we're going to do here is I'm going to show you just a very simple way of doing it, and it only involves one procedure, which is taking the square root. Okay, so you're going to see that as we go through all the examples. All right, so let's take a look at this first example here. So notice the two examples I have here are exactly the same. Two terms separated by minus sign, and notice the term that's missing there is the x term. So how in the world are we going to do this? Well, step number one, we're going to write two sets of brackets. Okay, now this is where it's very special only for this type of factoring. Okay, when you're looking at a difference of squares, you're going to write two sets of brackets, and in the first bracket in the middle, you're going to put a plus sign. In the middle of the second bracket, you can put a minus sign. Now, you notice we haven't done any math just yet, and we're just setting it up for what we're about to do in the next example here, or next step. So all we're going to do in the next step here is we're going to take the square root of each term and then place them in the spot that where they belong here. So when we take the square root of an x squared term, that just changes that to an x. Okay, now since the x squared is in the first spot in the question, the x on its own is going to be in the first spot in each bracket like that. Okay, square root of 16, that's going to be 4. Okay, and that's going to go in the second spot. Okay, that's factoring in different squares. As I said before, the technique behind it, the math behind it is not difficult. Just remembering to do it. Okay, that's going to be the challenge part. Now, just double check if we're on the right track over here. We're going to take this question here, and we're going to perform FOIL like we did in the first lesson here. So when I multiply the two x's together, that'll give me x squared. And when I multiply the x to the negative 4, that's going to give me negative 4x. So when I multiply the 4 to this x over here and the 4 to the negative 4, that's going to give me negative 16. Now, notice that in this one here, when we group the two middle terms together, okay, they cancel out, okay, and we get 0. So that's how we wind up for the final answer there of x squared minus 16. So just double check, notice the answer for the check is exactly the same thing as a question that we started off with. This is just to make sure that we're on the right track there, all right? Okay, this next one, again, follow the exact same steps. Two brackets. First bracket has a plus in the middle. Second bracket has a negative sign in the middle. Now, this one over here, the only difference for this one is that I just put the number in the first term just for something different. So when we take the square root of 100, that's going to give me 10. Now, since the 100 is in the first spot, the 10 will also take the first spot in each bracket like that. All right. And then from here, the x squared, when we square root it, that will give us the x, and it goes in the second spot. And that's pretty much it. All right, so just to do the check over here, okay, we're just going to take that, and we're going to multiply the 10 to the 10 and the 10 to the negative x. So that's going to give me 100 minus 10x. And then when I take the x and multiply the 10 and x to the negative x, that's going to give me negative x squared. All right, take the two middle terms together, they cancel out, and we wind up getting the same thing. All right. And that's pretty much it when it comes to factoring difference of squares. Same technique. Now, this next example is slightly different because you notice there happens to be a number in front of this x squared over here. Now, when you take a look at these questions here, all the questions that all the numbers, if you haven't noticed by now, okay, have when you take the square root of it, okay, it's always going to give us a whole number. So in some cases, you might get a question that kind of looks like this, okay, but when you take the square root of a number, it gives you a decimal. Okay, that's how you know that it's not a difference of squares, but we'll worry about that when we get to that issue. All right. So the difference with this one here is that when we're taking the square root part, okay, not only do we have to take the square root of the x squared, but you also have to take the square root of 9 as well. So when we put that together, the square root of 9x squared, that's going to give me 3x. Okay, and the 3x is going to go in the first spot. Okay, and as you can see, the square root of 25, that's going to give me 5. That goes in the second spot. Okay, and that's the only difference with this question here. So when we do the check over here, okay, multiply the 3x to the 3x and the 3x to the negative 5. So 3x times 3x will give me the 9x squared. Okay, and then 3x times negative 5 will give me the negative 15 here. And then 5 times 3x will give me plus 15x. And then 5 times negative 5 will give me negative 25. So when we group the two middle terms together, they cancel out, and sure enough, we wind up with the same expression as a question. All right. Now, you do not have to do the check every time. I'm just doing it for demonstration, just to show you again how it applies in this case. Because remember when we did the binomial distribution in the first lesson? Okay, we always wound up with three terms there. Just to show you that when you also do binomial expression and you have something like this, you can also wind up with two terms as the final answer. All right, so that's just for demonstration. All right, so last thing I want to do here is just do a quick word problem dealing with difference of squares, and we have a screenshot. Ooh, look how old that is. Little old Microsoft Windows there. All right, so a screen capture of web page is measured by its area, and the area is given to us in terms of x squared minus 18, or 81, sorry. And what we want to do here again is just factor this out using a difference of squares here. So when we do that, okay, we start off with two brackets like we did. Now notice I have the instructions here for reference over here, and you're going to see it's the same steps every single time. So plus in the first bracket and a minus sign in the second bracket. So what we have here is taking the square root of x squared, which gives me x. So that's going to go in the first spot here and the first spot here. Square root of 81, that's going to give me 9, goes to the second spot. All right, and that's it. Okay, now just to add to this question over here, using the expressions, we just want to actually use this. So it says, using the expressions from A, which is this part over here, calculate the area when x is equal to 20. So all I'm going to do with this question here is to replace 20 in for the x's, like so. Okay, next up here, I'm just going to simplify each bracket separately. So 20 plus 9 will give me 29, and then 20 minus 9 will give me 11. And last but not least, multiply these two numbers together, gives me 319 square meters. All right, so just a quick word problem to apply what it means to have a difference of squares there. All right. Okay, so that wraps up today's lesson here. So the next lesson we're going to be looking at, it's probably the most difficult of the three types of factoring, and that deals with factoring a trinomial in the form of y equals ax squared plus bx plus c. So if you haven't printed out a multiplication table sheet, okay, now would be a good time to do it, because again, it's going to make things a lot easier for what we're about to do in the next lesson here. So until then, I'll see you in the next lesson.